Hello everyone, welcome back to our class of SPSS. So in the last lecture we have seen ANOVA test, its assumptions, what are its conditions, okay, and when can we use this ANOVA, what is its importance, how can we use this ANOVA. A brief explanation was seen in the last lecture. If you have not seen that video still, you can go to the ANOVA test using SPSS in part 1 and you can just go through that video. Okay, so today we will be seeing ANOVA test in computing in SPSS. Now, in the lecture we have discussed that ANOVA was of two types, that is one-way ANOVA and two-way ANOVA. So today we will be seeing one-way ANOVA, computing one-way ANOVA using SPSS. Now let us take an example for that. Now here I have taken an example of gasoline sale output. So if you see that the oil company has introduced a new brand gasoline in its outlets in 3 major metro cities. As they are not sure how the new brand is selling, they have collected the following data as you can see on the screen for 30 selected outlets. Okay, now here we need to segregate which are independent variables and which are dependent variables. So in a one-way ANOVA, what we are having is one independent variable and a dependent variable. So one independent variable is here what? The major metro cities. Okay, so here in all metro cities are the independent variable and the volume, that is the sales of this gasoline, okay, sale output in volumes is given, so that is our dependent variable. So metro city, there are in all 3 metro cities, so 3 factor level are our independent variables. Okay, so what we are going to test in this? We are going to test the hypothesis. Firstly, the average sale of new brand gasoline is same in all the 3 metro cities. Nextly, the average sale of gasoline in Metro 1 is same as that of Metro 2. The average sale of new brand gasoline in Metro 1 is same that of Metro 2 and 3 together. So these are the hypotheses we are going to test using one-way ANOVA in SPSS. So you can see the first hypothesis is a simple hypothesis, whereas second and third are the complex hypothesis. So we are going to learn how to analyze a simple ANOVA also and going further to a complex hypothesis. Okay, so let's begin. Take our first hypothesis, the average sale of new brand gasoline is same in all the metro cities. So we will be stating here the hypothesis as they are same in all the metro cities, and alternate will be it is not same or it differs in all the 3 metro cities. This is what we have stated the hypothesis. Now nextly, what is the procedure to test in this in SPSS? Firstly, you need to import the data. Next, you go to analyze, compare means, then one-way ANOVA. Next, transfer volume to the dependent list as volume is a dependent variable. And next, transfer metro to the factor box, that is independent box. So let's see how we can do in SPSS. So I'm opening here the SPSS and you can see the data I have already imported. Outlets, metro and the volume. Okay, if you go to the variable view, you can see here that the outlet should be in scale, metro, it is a nominal, major and volumes in scale. So this is how you have specified now. Next, now computing one-way ANOVA. For that we need to go to analyze, then compare means, then one-way ANOVA. Now in one-way ANOVA, dependent is what our volumes and metro is our factors. Okay, nextly go to options. In options, click on descriptives, homogeneity of variance test. If you want mean plot, otherwise no, it is okay. Then click on continue. Now here, the homogeneity of variance test is one of the assumptions of testing the ANOVA. So it is very much important to know first the homogeneity of variance test and then only we can proceed to the ANOVA. So click on continue and then OK. So the output is in your output window. You can see first table is about descriptives, second is test of homogeneity, and thirdly the ANOVA. So first, going through the descriptives, you can see N is the number of samples, 10, 10, 10 in each of the 3 metro cities. Okay. Nextly, mean, you can see there is a difference between these means. There is a means this mean vary in each of the 3 metro cities. Okay, this is a brief description about the data. Now, moving further, that is the test of homogeneity of variances. Now, let me explain you this. What is the test of homogeneity? Now, you can see we have got the table called as test of homogeneity variances. It is getting what a Levin statistic. Okay, so Levin statistic is a statistics which will be going to explain you the homogeneity of variances, or which will be describing the homogeneity of variances in your taken sample. So here, how this statistics is specified? It depends on DF1 and DF2. Now what is this DF1 and DF2? DF1 is K minus 1. What is K here? The number of groups or the number of factor levels. So we have in all 3 metro cities. So we have is what? 3 groups. That's why K is equal to 3. 3 minus 1 is 2. That's why what will be the DF1 is 2. Nextly for DF2. Now this DF2, it depends on the total number of observations. So we had in all 30 outlets or 30 sample data. So this 30, what we are doing is, that is called as N. N is equal to 30. N minus K is the formula for DF2. So N is 30 minus K, that is number of groups is 3. So 30 minus 3 is equal to 27. And both of these having that, we are going to specify the Levin statistic, that is 2.750. So this is depending upon DF1 and DF2. So how can you interpret this Levin statistics? It is based on the significant value. Here the significant p value is 0.082, which is greater than 0.05. Hence, we can say that there is a homogeneity in the groups, whatever it is there in the 3 metro cities. So this is what giving us a further expansion to test the ANOVA test, because one of its assumptions is been true, that group variances are homogeneous for the given data. So next table was of ANOVA. So how are you going to interpret this ANOVA? Now you can see here volumes, it is given between groups and within groups. Okay, sum of squares is there, then degrees of freedom, mean square is also there, then this is the F statistics, and lastly the significant value. So while interpreting the ANOVA, you are going to look at the significant value. Here significant value, p value, is less than 0.05. This means you are going to reject the null hypothesis. Then what will be our final result? Rejecting the null hypothesis, we can conclude that there is an average sale of new brand gasoline. It is not same or it differs in all the 3 metro cities. This is how we have been created a result by analyzing the one-way ANOVA using SPSS. Now for the second hypothesis, which is a complex hypothesis, that the average sale of gasoline in Metro 1 is same as that of Metro 2. Now here we are not considering the Metro 3. So it is been excluded. So how can you test this ANOVA for the Metro 1 and Metro 2? Okay, so this comes to a complex hypothesis. Now we need to first specify again the hypothesis. The average sale of gasoline in Metro 1 is same as that of Metro 2, and it is not same or it differs in Metro 1 and Metro 2. Then the procedure in SPSS, it is same as we did for the first. Only the last thing that we need to click on the contrast and enter the contrast -1, 1 and 0. Now what are these contrasts? Contrasts are very much useful in testing complex hypotheses. So what is that? Let's see. Firstly, It is used to test complex hypothesis. Nextly, it is used as a conjunction with ANOVA or a multiple regression. Nextly, contrast defines and tests for a particular pattern of differences among the means. Means here what we are doing is we are taking metro 1 and metro 2, that is the pattern which you have fixed, except the metro 3. So it is what the contrast will be defining the factors that you want to test for ANOVA. You want to see the differences in those means, so that will be defined by the contrast. Nextly, the approach is developed to set weights that eliminate any group means that are not involved in the comparison. So in our case, we are excluding the metro 3, that is what remaining two, metro 1 and metro 2, we are giving is what weights we are giving to them to compare the means of that. So this is the basic use of contrast in SPSS. Lastly, this is done by giving what the zero weight, while the groups that are to be compared giving them as 1, -1 and +1. So these are also called as planned contrast. So we are here planning that in which two groups we want to see or we want to compare the means. Okay, excluding the other, we have to give zero weight to that, and remaining two we can give -1 and +1. Like for a black dress, we are having a white background. Okay, for a photography, similarly here we are going to give -1 and +1, which are the contrast, and zero for the group which are not, which is excluded for the comparison. So let's see how to do this contrast in SPSS. Now again go to analyze, then go to compare means, then one way ANOVA. Okay, so here already for the first example it was set. Now nextly you can go to the, just click on contrast. Now here you can see the contrast. Coefficients you need to add here, and the coefficients total you can see is 0. So whatever coefficients you are going to add for the given groups, its total should be always 0. Okay, so for this I will be giving for metro 1 as -1. Okay, then for metro 2 as 1. In both these only we are going to compare the results, excluding the other. So metro 3 we need to give is 0, that is we are giving its weight in a contrast. So total coefficient you can see it is now 0. Okay, so it should be always 0. In that conditions you need to give the coefficients. Then click on OK. Then click on OK. Now you can see here the contrast test. Okay, now contrast you can see here for metro 1 I gave -1, for 2 1, and for 3 0. Similarly here you can see contrast, it is assuming for volumes assuming equal variances and does not assume equal variances. So for the homogeneity test we have seen that we have accepted the null hypothesis that there is a equal variance. So we are going to see for the equal variance what is the significant value. So it is 0.000. So let's go to the results again. What we can specify from that, that is the p-value is less than 0.05. So we are rejecting the null hypothesis. And lastly, we can conclude that the average sale of gasoline in metro 1 is not as same or it differs as that of metro 2 respectively. So this is how we have seen, or we have been conducted the complex hypothesis of for metro 1 and metro 2 cities. Okay. So let's go to the third complex hypothesis. Now this is much more as compared to second hypothesis. The average sale of new brand gasoline in metro 1 is same as that of metro 2 and 3 together. Okay, so we need to state the hypothesis again. They are same in all, metro 1 is same as that of metro 2 and metro 3 together, or they are not same or they differ from the metro 2 and metro 3 together. Now already what we have done is we have given the contrast, that is -1 and 1 for the metro 1 and metro 2. Now how you are going to count this total number of contrast? Okay, you can note this, that we are going to count this total number of contrast, or how many maximum contrast we can make is, that is total groups minus 1, that is k minus 1 again. So it is 3 minus 1, that is 2. So you can make only 2 contrasts. So already one contrast we have done. Now it is the time for making second contrast, second possible contrast. Now how can we do that? See the procedure. Again, we need to go to analyze, compare, means and all. Then we are going to transfer the volume. This already we have done. Nextly, you can see here you are going to click on the contrast again, and you are going to enter here this time 2, minus 1 and 1. Now why 2? 2 is for the metro 2 and metro 3 together. Okay, minus 1 is for the metro 1 again, and 1, because we are going to give equal weightage to all of 3. Okay, we have not excluded this time any of the metro city or any of the factor. So we are going to give here the weightages 2, minus 1 and 1 as the coefficients in SPSS. Now how can we do this in SPSS? So again go to analyze, and you can go to compare, means one way ANOVA, again contrast. Now here you can just remove this. Okay, so you can remove this. Now you can put 2 for both the contrast, minus 1. Now this should be again balanced, so we are putting 2, minus 1 and 1. Okay, click on continue, click on OK. Now you will be getting here the contrast. Now contrast you can see for metro metro 1 2, for metro 2 minus 1, and for metro 3 is 1. So equal weightage is given here to balance the coefficients. Now our variances were equal, so we are going to see assume equal variances, significant value. Now again here the significant value is 0.00. So let's see how we can state the results. So p value here is 0.003, which is less than 0.05. So we are going to reject here null hypothesis, and you can state that the average sale of gasoline in metro 1 is not as same, or it differs that in metro 2 and metro 3 respectively. Okay, this is how you are going to do. This is how we have now done is what? The complex hypothesis, the third complex hypothesis. First hypothesis, we tested that whether it is same in all the metro cities. Nextly, we excluded one metro city and we tested for the other 2 metro cities. Now lastly, what we have done is we have compared the metro 1 with metro 2 and metro 3. So total number of contrast, or total number of comparisons, or total number of cases we will be having here is total number of groups minus 1, that is 2. So total 2 possible contrasts were possible in our given example. So this was about testing one way ANOVA hypothesis using SPSS. Now nextly, like to share you with the post hoc test in SPSS. Now what is this post hoc test does? It is used to determine which mean or the group of means that significantly differ. Okay, which has significant F. Means the post hoc test will be giving you that in which of the pairs does there is any significant changes, or what is the we can determine the mean for that. Means now we can compare the metro 1 with the metro 2 and metro 3. Now sometimes if it is not significant, then we can go for the post hoc test and we can see that which of the pair is not significant, whether metro 1s with metro 2 or metro 1s with metro 3, or for metro 2 with metro 1, metro 2 with metro 3 similarly. So like this, a group wise where we can compare using what? Post hoc test in SPSS. Now you can see here, depending upon the research design and research questions, we have 3 specified here the post hoc tests which are usually used. So first is Bonferroni, that is most powerful test. Now it is used only some pairs of samples mean are to be tested, desired at alpha level. and divided by its number of comparisons. Okay, now we can have a direct option of the Bonferroni test in the post hoc test, so you can directly click on that. Next is Tukey's. This procedure is followed for all the pairs of sample means that are to be tested. And lastly is last procedure, you can have it for the if the sample sizes are equal, that is Schneeschrift's procedure. Okay, so let's have a quick review of what are the how this post hoc test is done in an SPSS. Now again you need to go to compare means and one mean. Now already the data has been put, so you can see here the post hoc test option is there. So just click on that. You're having numerous tests. So most appropriate is Burnout. So you can, if you see that if the sample sizes are unequal, then only we are going to use this Naishift procedure, otherwise not. So we can use Turkeys or Bonferry. So we will be seeing this Bonferry and just continue. Click on continue and click on OK. Now if you scroll, you can see here the pairwise comparison is given. Okay, the Metro 1s with Metro 2 and 3, Metro 2s with 1 and 3, Metro 3s with 1 and 2. And you can see the significant values here. Now for the Metro 1 and 2, you can accept the hypothesis. For Metro 1 and 3, you are rejecting the hypothesis. Similarly, for Metro 2 and 1, you are accepting. For Metro 2 and 3, you are accepting. Okay, so Metro 1, 3 and 1, you are rejecting, and Metro 3 and 2, you are again accepting. So like this, this gives an actual pairwise comparison in which actually the means differ while comparing the means. This is the most used in the many of the analysis, so that we can properly identify which of the groups are significant or they are insignificant. So this was all about the post hoc test in SPSS. Hope that you all have completed, you all have understood, and so that you can make a proper analysis using ANOVA test in SPSS. Thank you.